In our day-to-day activities, some questions arise. In how many ways can I invite my friends who are 8 in number and my table can accommodate only 6? Such questions do occur in our daily affairs. Similarly, a question arises as to how many diagonals does an octagon have. An octagon is an 8-sided figure. All these and much more questions will be answered when we study the next chapter called Permutations and Combinations. To study and learn more about it, we have to study some basic facts. They are: the first concept that we have to understand is what is factorial. Let n be any whole number, that is, either it is a 0 or it is any natural number. N factorial is defined as the product of 1, 2, 3, 4, dash, dash, dash up to n, where n is belong to natural numbers n. Thus, 1 factorial equal to 1, 2 factorial will be 1 into 2, that is 2, 3 factorial is equal to 1 into 2 into 3, that is 6, etc., etc. Factorial n is not defined for any negative numbers or any fractional number. Clearly, n factorial is equal to n into n minus 1 factorial, or n into n minus 1 into n minus 2 factorial, or n into n minus 1 into n minus 2 into n minus 3 factorial. Let us study 2n factorial. 2n factorial means 1, 2, 3, 4, so on, their product, up to 2n minus 2, 2n minus 1 and 2n. If I pull out even and odd integers separately, we get the first factor as 2, 4, 6, 2n minus 2 and 2n. The second is 1 into 3 into 5 into 2n minus 1. In the first group of even numbers, we can pull out 2 common from each factor. That becomes equal to 2 raised to power n, because 2 can be pulled out from each of the n factors. That gives us 2 raised to power n multiplied by 1 into 2 into 3 up to n minus 1 into n. The other factors being 1, 3, 5, so on up to n minus 1, which is equal to 2 raised to power n. 1, 2, 3, 4 up to n can be replaced by n factorial into 1 into 3 into 5 into 2n minus 1, equal to 2 raised to power n into n factorial into 1 into 3 into 5 into 2n minus 1. It's a very important result. Note that m plus n factorial is not equal to m factorial plus n factorial. Similarly, 2n factorial is not equal to 2 into n factorial, and m into n factorial is not equal to m factorial into n factorial. These are 3 important mistakes. The concept of permutation and combination depends on 2 fundamental rules. First, the addition rule. Suppose a work A can be performed in m different ways, and another work B can be performed in n different ways, which does not depend on the work A. Then A or B, that is at least one of them, can be performed in m plus n ways. This rule is called addition rule and can be extended to more than 2 mutually exclusive events. The second rule is called product rule. Suppose a work A can be performed in m ways, following which a second work B can be performed in n ways. Then the two works in succession can be performed in m into n ways. Suppose I have 4 shirts and 3 pants. Then I can dress up in 4 into 3, that is equal to 12 ways. Because corresponding to every shirt, I can use one of the 3 pants. Since there are 4 shirts, naturally the number of ways in which I can dress up is 4 into 3. That is what I have used as the product rule.